Hello everyone, this is Math with Zanger. Welcome back to my AP Calculus class. We are starting up with Unit 0, Pre-Calculus. In this unit, we have four categories: functions, properties of functions, elementary functions, and sequence and series. In today's video, I will go over 0.1 functions. These are the functions that you will see in AP Calculus. So what is a function? A function f from a set A to a set B is a relation that assigns to each element x. In the set A, exactly one elementary y in the set B. The set A is the domain or set of inputs of the function f, and set B contains the range or set of outputs. Our first function, linear equation. Y equal to mx plus b is the standard form. M is the slope and b is the y-intercept. Y-intercept means when x equal to 0, and you can plug in the value to find b. As you can see from the graph, when the slope is positive, the line rises. If it is negative, line is going downwards. And we can find m, the slope, by using changing y over changing x, which is y2 minus y1 over x2 minus x1. Last things you need to know for linear equation. Point slope form. You'll see this often in AP Calculus. It is written as y minus y1 equal to m times x minus x1. Usually, the question will give you the equation and x1. Then you need to find the rest. I'm also going to introduce two relationships between lines. If two distinct non-vertical lines are parallel, they have the same slope. If they're perpendicular, the slope are negative reciprocals of each other. Second function, quadratic function. Fx equal to ax squared plus bx plus c. As you can see from the graph, if the parabola opens upward, then a is bigger than 0 and vertex is the lowest point. If it is open downwards, then a is smaller than 0 and vertex is the highest point. There is a standard form for quadratic function, easier to find the vertex, written as fx equal to a times x minus h squared plus k. The parabola whose axis is the vertical line x equal to h, and vertex is point hk. When a is bigger than 0, it opens upward. When it is negative, it opens downwards. Let's move on to polynomials function. It is a function of x with degree n. For example, fx equal to 5x to the power of 4 plus 4x squared minus 9. And the degree n is 4, which is a fourth degree polynomial function. Polynomial graphs are continuous and smooth curves. And these two are not polynomials. The first one has a jump discontinuous, and it's a piecewise function that you will learn in a few minutes. And the second one has a sharp turn. It is also a piecewise function made up with two linear equations. The leading coefficient test. The leading coefficient is an, the constant in front of the highest term of x, which helps to determine the end behavior. From the graph, when n is odd, the leading coefficient is positive, then the graph falls to the left and rises to the right. If the leading coefficient is negative, then the graph rises to the left and falls to the right. When the highest degree of x is even, if the leading coefficient is positive, then the graph rises to the left and the right. If the leading coefficient is negative, then graph falls to the left and to the right. 0.1.4 Rational function. It's a quotient or ratio fx equal to px over qx, where p and q are polynomials. The domain of a rational function is the set of real x, for which qx not equal to 0. From the graph, there are asymptotes. We will talk about more in the future. For now, you just need to know this function. A piecewise function, where we mentioned earlier, a function is described by piece by using different formulas on different parts of domain. For example, function x when x is bigger than equal to 0. Function is negative x when x is smaller than 0. These two pieces made up the function y equal to absolute value of x. And the second function is made up with three different equations with three different domains. So these are called piecewise function. 0.1.6 Composite function. where there are two functions, function f and function g. The composite function f composed with g is defined by f gx. The domain of f composed of g consists of the number x in the domain of g for which gx lies in the domain of f. Let's take a look at an example. Find f composed of g and g composed of x, and g composed of f. Fx equal to 2x squared minus 3x plus 8, gx equal to 5x minus 6. F composed of g, which is f gx, equal to 2 times 5x minus 3 times 5x minus 6 plus 8. G composed with f equal to g fx equal to 5 times 2x squared minus 3x plus 8 and minus 6. Finally, we're at our last function, inverse function. But before I introduce inverse function, we need to know a function called one-to-one function. A function when each value of a dependent variable corresponds to exactly one value of the independent variable. A function f has an inverse function if and only if f is a one-to-one function. For the polynomial with degree of 3, it is a one-to-one function. Every time you take a x, there's only one output, y. However, for the quadratic function on the right, it is not a one-to-one function, because we have two input with the same output. An inverse function only exists when the original function is one-to-one. This means each input has only one unique output, and each output comes from only one input. Suppose f is a one-to-one function with domain at D and range R. The inverse function is written as f inverse. It reverses the action of f, so if f a equal to b, then f inverse b equal to a. In simple words, if the original function sends a to b, then inverse function sends b back to a. The diagram shows the relationship visually. The function fx equal to x plus 4 moves from the input x to the output fx. The inverse function reverses the process. Since the original function adds 4, the inverse function subtracts 4. So f inverse x equal to x minus 4. The inverse function is the mirror image of the original function across the line y equal to x. When we find the inverse, we switch the x and y coordinates, so point like 2, 4 becomes 4, 2. This is why x squared and square root x are inverse functions. And that's all the 7 functions you need to know for AP Calculus. Please follow for the rest, and thank you for watching.